So these questions require quite a lot of practice, but they do tend to follow the same structure and format. So once you've got used to them, they're more accessible than perhaps they first appear. Let's read it carefully. The diagram shows a plan of a school running track. It consists of two straight sections, which are the opposite sides of the rectangle, and two similarly circled sections, which each of radius r meters. So that's basically what's on the diagram. The length of the track is 300 meters, and it can be assumed to be very narrow. Show that the internal area is given by the formula. So it's a standard kind of question where we've given info about perimeter and want something to do with area. So let's start from the beginning. Show that the internal area is, but we know something about the perimeter. So let's first find the perimeter. First find an expression for perimeter. So we've got a circle. So perimeter is equal to the circumference of a circle, 2 pi r, because we've got the 2 pi r is that bit plus that bit. And then we've got two lots of the length. So if we call this length here x and this length x, we've got plus 2x, and that's going to be the perimeter. Okay, I hope that's clear. Yeah, so those two give us that for the perimeter of the shape. Okay, now we're also told from the question that the perimeter is 300. So we can substitute in for the perimeter. 300 is equal to 2 pi r plus 2x. Now we also need, what we're actually asked for is the area. So we need an equation for the area. So the area is equal to the area of the circle, pi r squared, plus the area of the rectangle. Well, the area of the rectangle must be x times, and this length here, that we're looking at here, is going to be 2r. So the area of the rectangle is 2rx. Okay, now the problem here is that in our question, we're asked to show this, a equals 300r minus pi r squared. And we notice that there's no x's in here. There's no x in here. Therefore, must eliminate, usually by substitution. So we can see, I hope, from here, this implies 2x is equal to 2 pi, that's wrong, sorry, 2x is equal to 300 minus 2 pi r. And then I can substitute from this 2x into here, into this 2x. So I get area equals pi r squared plus r times 300 minus 2 pi r. If I expand that, I get pi r squared plus 300r minus 2 pi r squared. Tidy it up, 300r minus a pi r squared, collecting the pi r squared terms together, and that's as required. So it's a question that looks quite difficult, but with a bit of practice, you can use one of the bits of information in the question, in this case, the 300, enable us to work out an expression for x, which we could then substitute in. And they always work in that kind of way, but sometimes it might be surface area and volume, yeah? Or in this case, it was perimeter and area, but there's always two bits of information and one enables you to get to the other. Okay, hence find in terms of pi the maximum value of the internal area. You do not have to justify the value is a maximum. Do not have to justify the value is a maximum. So, well, to find maxes and mins, we differentiate, don't we? So A, we're going to differentiate the area with respect to the radius. So we're going to get 300 minus 2 pi r. And the turning points occur when that is equal to 0. So max min or turning points dA dr equals 0. Therefore, 0 equals 300 minus 2 pi r. So 2 pi r equals 300. R equals 300 over 2 pi, which is 150 over pi. Tied it up. Check what we were asked for. Hence, find in terms of pi the maximum value of the internal area. So the area, we're not justifying it's a max, so we can be pretty sure it's a max. Area is equal to 300 lots of r. So 300 lots of 150 over pi minus pi times 150 over pi squared. So if we take out the 150 over pi as a factor, that leaves 300 minus 150. He says, just checking that in my head. Yeah, because the pi's from the second lot cancel. Yeah, that's this pi with this pi when we write it out. So we've now got 150 squared over pi, which is 15 squared is 225. So we get 0, 0 over pi. Units squared. I don't know whether we're given any units. Yes, meters squared. And that's that one done.